Last time we were writing these expressions as a single logarithm. We got to problem 66 and we finished that one. Now let's do problems 68 and 70. So 68 gives us 1/3 log x cubed plus 1 plus 1/2 log x squared plus 1. So to write this as a single logarithm, the first thing I would do, notice that there is a plus sign and we would like to make that multiplication, but the only time we can do that is if the coefficients in front of the logs are 1. So let's get rid of these coefficients by sending them back up as powers on these things in the parentheses. So this is equal to log of x cubed plus 1 to the 1/3 plus log x squared plus 1 to the 1/2. And now we're going to use the multiplication rule that says that this is equal to log of x cubed plus 1 to the 1/3 times x squared plus 1 to the 1/2. Now if you want, you can write this as a square root and a cubic root if you like. I'm just going to leave it like this. All right, let's try the next problem. This is problem 70. We have 3 log base 5 of 3x plus 1 minus 2 log base 5 of 2x minus 1 minus log base 5 of x. We do have minus signs, which means that we're going to work with division. Again, the first thing I want to do is get rid of these coefficients. I want to put them at the as the power here. You have a couple of options with this too. You could send just 2, or you could send -2. You're going to get the same answer. If you send -2, then this will become a plus here. So what I'm going to do is I'm actually just going to send 3 here and the number 2 here. Okay, so we'll get that this is equal to log base 5 of 3x plus 1 cubed minus log base 5 of 2x minus 1 squared minus log base 5 of x. Now from there, I'm going to start from left to right. I'm going to combine these two first, and then I'm going to combine it with this one. So this is equal to log base 5. I have a subtraction that becomes division inside the log. And then the last step is to divide by x, this whole thing. Okay. So this is equal to log base 5. So how do we divide this by x? We're going to take this whole thing and put it in the numerator and then divide by x. So like this, 3x plus 1 cubed over 2x minus 1 squared. All of that is divided by x. Now there's so many division signs. I want to just have one division sign. So what I'm going to do is I'm going to take this numerator and I'm going to multiply by the reciprocal of this one. So I'm going to flip it. This is the same thing as x over 1. So then I can get rid of this denominator here if I multiply by 1 over x. So if I do that, and I'm actually going to put it right here. I'm just going to put this x down here in the denominator. So maybe I'm going to make it a little bit bigger. And then just make this line a little longer and stick that x right here. And now we have made this into a single logarithm. So we did all of the even problems. Let's move on. Okay, so if you remember, we were doing some problems in the last video. We did the problems in green, and then I said we would come back to the problems in blue. We should be able to actually evaluate these logarithms without a calculator. Let's see if we can do it. I think we'll be able to do 20, 22, 26, and 28. 24 is actually tricky, and I'll show you why in a minute. We'll discuss it, but we'll actually do this problem later. So let's start with problem 20. So 20 says we have log base 6 of 9 plus log base 6 of 4. Okay, I want to figure out the number that goes with this, this expression here. So remember that logs are exponents. So what I have is if I let this equal x and I let this equal y, I should be able to find x plus y. And remember, x is the power on 6, that gives us 9. So in other words, 6 to the x is equal to 9, and 6 to the y is equal to 4. So if I was able to find these two numbers, what I have to raise 6 to get 9, and what I have to raise 6 to get 4, if I just add them, it will give me the solution to this problem. The problem is, you can't really write 6 in terms of 9 and 9 in terms of 6. You could say something like, oh, well, I do know that 9 is 3 squared, but 6 is 3 times 2. It's not 3 raised to a power. So you can't break this down into break 6 and 9 down into powers of 3. And definitely you can't break 6 and 4 down into powers of 3. 4 doesn't break like that. 4 is 2 squared, but 6 is not a power of 2. So what can we do to get around this? Well, let's use the properties of logs that we just learned. I have a plus here. Maybe if I combine them into one log, I can do something with that. So this is the same thing as log base 6 of 9 times 4. And 9 times 4 is 36. And now we can actually evaluate this, because remember, the log is the exponent. So 6 to what power gives us 36? Well, that's 2. I'm just going to write the reasoning here. So the solution to this, adding these two logs, although we couldn't solve the logs the way they were already presented to us, by using that property of logarithms, where the addition on the outside becomes multiplication on the inside, we were able to find the value of this expression. Okay, let's try, so we did 20, let's try 22. Okay, so 22 gives us log base 8 of 16 minus log base 8 of 2. We're going to have a similar problem here. We can't evaluate these logs without a calculator by hand. We would have to put this in the calculator to figure it out. But maybe we can use a rule of logarithms to solve it. So maybe pause the video and try to solve this on your own and see if you get the same thing I get. Okay, well, subtraction becomes division on the inside of a log. So this is log base 8 of 16 over 2. And 16 over 2 is 8. And this was actually one of those properties we had to memorize, but if you don't remember it, you could figure this one out, because 8 to the power 1 is 8. So this is just equal to 1. Remember, it's the exponent. So 8 to the power 1 gives us 8. So we did 22. Now let's briefly talk about 24. 24 is log base 3 of 8 times log base 8 of 9. So we have a few problems with this one. First off, we have multiplication, but multiplication only becomes addition when it's inside a logarithm. Here, this multiplication is on the outside of two logs, so I can't use that rule involving addition and multiplication. Also, these logs have different bases. This is a 3 and this is an 8. Remember that all of the rules we saw so far, the base of the logs, like when we had addition, the bases were the same. So with this problem, we don't have the tools to figure it out right now. So we're going to skip this one and come back. Okay, let's try problem 26. Get some space here. So problem 26 says we have 5 log base 5 of 6 plus log base 5 of 7. So notice that all of this log stuff is inside the power of 5. This log 5, 7 is not being added to this one. What I'm saying is this is not equal to 5 log 5, 6 plus log 5, 7. This is up in the exponent. So how can we solve this? Well, there's actually a few ways to do it. Hold on just a second. Let me move back. Okay, we were right here. I'm going to show you 2 different ways to do this problem. Now, you might notice off the bat that we have 5 log 5, which is a property we learned a while back, which if we had something like a log a of b, this was equal to b. And that's true, and we can use this, but this rule does not apply when you have sums like this. It only applies when you have a single log in the exponent. So you either have to combine these logs or break this in some other way. So one option you can do, I'm going to show you, is that this is equal to 5 log base 5, 6 over 7. Not 6 over 7, what am I talking about? It's 6 times 7. Because we have addition here. Addition becomes multiplication. Okay, so 6 times 7, what is that? Well, that's 42. So let's erase this and put 42 here. And now I can use this property. I have 5 log 5, so this goes away and we're just left with 42. I mentioned there's another way to solve this. So let me erase this. Remember that if you have a raised to the m plus n, this is the same thing as a to the m times a to the n. So this is the same as 5 log base 5 of 6 times 5 log base 5 of 7. And now you can use that rule again, where if you have some letter here, like a log a, you get rid of it and you just get this number. So we'd have 6, and then we have this multiplication sign, and then this 7. So we get 42 again. Okay, and let's try the last one here, 28. 28 is e log e squared of 9. At first glance, you might think, oh, I can do the e log e of 9. I can cross this out. But notice that I have a squared here. So that rule doesn't apply here because it has to be, whatever I have here, I have to have the same thing here, and I don't. So what can I do to figure this one out? This one's actually kind of tricky. I'm going to force this e, I'm going to make it e squared. How can I do that? I can't just stick a 2 there because then I won't have the same problem. But I do know that 9 is 3 squared. So this is the same thing as e log e squared of 3 squared. And now that I have a 2 here, I can send it in the front here. So I have e squared log e squared of 3. And now what can I do with this? Remember, if you have a raised to m times n, this is the same thing as a to the m times n, or you could switch these two. You just multiply them. So that's what I'm going to do here. This is equal to e squared log base e squared of 3. And now I have that, the same number here, I have it here as well. So I can cross these out and I'm just left with 3. Yeah, that was kind of tricky. I had to really think about what I needed to do here. And so if you didn't see it at first glance, that's okay. Just as long as you understand the rules that I'm using, that's what's important. All right, so next thing we're going to talk about is the change of base formula. So we've talked about the change of base formula before, but now I'm going to actually prove the change of base formula. So if you remember, I mentioned that a lot of calculators, they only have two types of logs that you can plug in. You can plug in something like log of 7 and ln of 7, but they don't have the option to plug in log base 3 of 7. Now remember, if you just see the key on your calculator that says log, that's log base 10. So it's understood that the base is 10. And that's not what we have in this problem right here. And when you have ln of 7, the base is understood to be e. So this is log base e. But how would we be able to solve something like this? Well, we're going to use the change of base formula, which says that this is equal to log base 10 of 7 over log base 10 of 3, or this is equal to ln of 7 over ln of 3. So when you have some strange log that you need to solve, and you don't have a key in your calculator, you just choose either the log or the ln and press it in your calculator. So you say log of this one over log of that one. We'll prove it in just a second. I'm actually going to put it in the calculator for you to see. And then I want to discuss where this rule came from. So let's switch over to the calculator. All right, so we had log base 3 of 7, I believe it was. Let me just, sorry about that. Yeah, log base 3 of 7. See, this calculator allows me to put different bases down here, but you see I get 1.7712. Now if I do log of 7 divided by log of 3, I get the same thing. And if I do ln of 7 over ln of 3, I get the same thing. And in fact, you could choose any base you want. You could do log base 5 of 7 over log base 5 of 3, and you're going to get the same answer. We're just choosing log base 10 and log base e because they're easy to put in your calculator. Okay, so let's go back to here. So why is this true? Why can we do this? Well, let's put this in white here. So log base 3 of 7, let's set it equal to x. Well, that means 3 to the x is equal to 7. So if this is equal to some number, and remember that this is an exponent, so 3 to that power gives us 7. Now what happens if I take the log of both sides? Now remember what we said, there was a rule that says if m is equal to n, then we can just put a log, any log we want, in front, and these will be the same. Well, here I can let this be m and this be n. So log of 3 to the x is equal to log of 7. And because that's true, I have a power, then x log 3 is equal to log 7. And then to solve for x, you can say x is equal to log 7 over log 3, which is the change of base formula. Now I chose base 10, but because of this rule here, you could put ln in the front. And then if you pull the x down, you would divide by ln 3, and this would be ln of 7. Remember, you have to have the same base here, so we can't do log base 10 and log base e, can't do that. You have to have the same base. So when I chose that number 5, I showed you in the calculator, I put a log base 5 here and a log base 5 here, pulled the x down, and I got log base 5 of 7 over log base 5 of 3. And so that's why it was equal in the calculator. Again, I can't change these numbers, they have to be the same. So what I would like you to do is I would like you to try to put some of these in your calculator. So choose the calculator. If you have a TI-83 or something like that, you can plug these in, or you can plug them into Desmos and see if you can solve them. So maybe let's do, let's say 72. This one's a strange one, so 76, and maybe let's go with 78. So put them in your calculator and see what you get, and then compare it to what I get. Okay, here are my answers for these problems. I got log base 5 of 18 is 1.8, log base square root 5 of 8 is 2.58, and log base pi of square root of 2 is 0.3. I'm going to show you what I did in my calculator. So let me switch over. I did this a few ways, like log base 5 of 18. I actually used this base 5 in Desmos, and I got this. But I also tried it this way with using the natural log. So I got the same answer. And here I did log base square root 5 over 8, and I did it also with log base 10, so the common log, and I got the same answer. And here I just did it one way. I used ln of square root of 2 over ln of pi for that last problem. Okay, so let's go back to here. And now we're going to look at that problem we skipped and we said it was a little tricky. This is log base 3 of 8 is equal to log base 8 of 9. I want to solve this without using a calculator. You can use a calculator, you can multiply them, and you're going to see something interesting happen. You're going to get a very strange number for this one, a very strange number for this one, but when you multiply them, you get a nice number. Here, we can even try that in the calculator. As you can see, log base 3 of 8 is this 1.89, this really large number. Well, it's not a large number, but a lot of decimals is what I mean. And here I also have a lot of decimals, but magically when I multiply them together, I just get the number 2. So we should actually be able to do this by hand because we get such a nice number. Okay, so let's see what we can do. We have log base 3 of 8 times log base 8 of 9. I like to write things out again because when I write them, I start thinking about them. So notice that to work with these, maybe we should use the change of base formula. So what I'm going to do is I'm actually going to try to switch the logs to either a log base 3 or a log base 8. Let's go with log base 3. So I'm going to keep this one like it is. And I am going to switch this one to log base 3. Now, how can I do that? Notice that log base 8 of 9, we said that we can use this change of base formula. We said it was any log that we wanted with the 9 here, and then we put the log with the smaller number down here. And you can use any base you want, and I'm going to use base 3. There's a reason for that. Because if I do that, I get this is equal to log base 3 of 8 times log base 3 of 9 over log base 3 of 8. And then, since this is over 1, notice that these two cross out. And I'm just left with log base 3 of 9. This is something I can simplify because this is equal to log base 3 of 3 squared, and that's equal to 2 log base 3 of 3, which is just 2. Or you could just ask yourself 3 to what power gives you 9, and you would say, oh, that's 2. So we did get 2. Now we could also use log base 8, but we would change this one instead. So let me show you how to do that part of this problem. So I'm just going to erase all of this. Okay, so this log base 3 of 8, this is the same thing as log base 8 of 8 over log base 8 of 3. This is the base I'm choosing to use. And if I do that, I get that this is log base 8 of 8 over log base 8 of 3 times log base 8 of 9. Okay, can I finish this problem? Am I able to solve it? Well, let's see. This log base 8 of 8, that's just 1, right? So then I get that this is equal to log base 8 of 9 divided by log base 8 of 3. Okay? At this stage, notice that we have a division with logs, but the division going into subtraction only works when the division is inside a single logarithm, so we can't use that rule. So you might be stuck here, but notice that this 9 can be written as 3 squared. So this is equal to log base 8 of 3 squared over log base 8 of 3. And I can pull that 2 in the front. So I get 2 log base 8 of 3 over log base 8 of 3, and these cancel, and I'm left with 2 just like earlier.